we're going to keep going and just try to finish off this problem really quick. Cosine on the right hand side, cosine theta plus 1 is equal to 0. That means that my second answer is cosine theta is equal to a negative 1. Okay, so I'm going to have a bunch of answers for my theta, so let's try to figure this out. Cosine theta is equal to a negative 1/2. Now, what I want you to think about is, alright, so my answer for cosine is negative value. That means that I'm going to have answers in two different quadrants. Wherever cosine is negative, I'm going to have an answer. We know that cosine is positive in the first quadrant and the second or the fourth quadrant, so I'm going to have an answer in the second quadrant and in the third quadrant. Now, the reference angle formula for these quadrants are 180 minus theta and 180 plus theta. However, we don't know what theta is. Theta is supposed to be our reference angle in the first quadrant. That is not one of our answers because we don't want a positive value. However, we still need to know what the theta is. We still need to know our reference angle. So I'm going to try to figure that out. There's a couple of different ways that I could figure it out this time. I could use my calculator, and I could do second cosine of a positive 1/2, because if I put in second cosine negative 1/2, you're just kind of running the risk that you're going to get the wrong answer. So you want to do positive value because that's what's going to tell you what your answer is up here in the first quadrant. So second cosine positive 1/2, that's going to be equal to 60 degrees. The other way that I knew that was because it was on our magic table. Okay? So hopefully if you have the magic table memorized by now, or if you have it out in front of you, you could have been able to recognize that as well. Now, 60 degrees is not one of our answers. It's just the reference angle. It is what we use to figure out the two answers that we are going to count. So theta is equal to 180 minus 60 gives me 120 degrees. 180 plus 60 gives me 240 degrees. So those are the two answers that I'm going to have from my first answer over here. Now, when I'm looking at my second answer, cosine theta is equal to a negative 1. Whenever you have an answer that's positive 1, negative 1, or 0, which we do, you're going to take a look at the unit circle, because all those values are on the unit circle already. Cosine is the x value. So if I go around and I label all these points, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. I'm going to look for all the places where the x value, where cosine, is equal to negative 1. And it's only equal to negative 1 at one spot right here, which is 180 degrees. Now, you could have used your calculator to do that as well. However, we're just trying to be smart mathematicians and think about this stuff logically without just punching things into our calculator. Okay? So these are the three answers that we get for this problem, and the only really tricky part about this was that we had to substitute in for a double angle right at the beginning. But after that, the rest of it was pretty easy. Okay. Secant squared theta minus tangent theta minus 1 is equal to 0. What's the problem with this equation? The problem is that we have two different variables. We have secant squared theta and we have tangent theta. That's not good. We don't really like that. So we're going to have to fix that. Let's think about how we could do that. Let's think about, I don't know, different ways that we could think about this. Something that pops into my head is maybe I could write this secant as 1 over cosine squared theta. And then tangent could be written as sine squared over cosine squared. However, so we have a common denominator, but the only problem with this is we still are dealing with an equation where we have two different variables, cosine and sine. So, I mean, yeah, we rewrote it a different way, but it didn't really help us. So let's try to think of something else, a different way that we could figure this out. You should know by now your Pythagorean identities. Let's make a new sheet for this. There are a couple of different Pythagorean identities that you need to know. There's sine squared theta plus cosine squared theta is equal to 1. That's the easy one. And the only reason why I'm doing this, John, is because I see that this is a secant squared theta. So I know that in my 3 Pythagorean identities that I'm going to have, I know that one of them has a secant in it somewhere. And I'm thinking maybe I could rearrange one of those equations and get secant by itself so that I could rewrite it somehow. So let's try to figure this out. I know that if I go through this and divide everything through by sine squared, I'm going to get my second Pythagorean identity. Sine squared theta divided by sine squared theta is equal to 1. Cosine squared theta divided by sine squared theta is equal to cotangent squared theta. And 1 over sine squared theta is equal to cosecant squared theta. So I don't see a secant squared in that equation. So that one, I guess, didn't really help me. I guess it's going to be the third and last one. So how about we try this again? How about we divide everything through, this time by cosine squared theta. And I hope you know what I mean by, I'm just kind of trying to abbreviate so I can do this quickly, because I know that we have a lot more important things to do. So sine squared theta divided by cosine squared theta is equal to tangent squared theta. Cosine squared theta divided by cosine squared theta is equal to 1. And 1 divided by cosine squared theta is equal to secant squared theta. Now that's the equation that I want to look at, because this is the one that has secant in it. So what did we learn from this equation? Apparently, secant squared theta is equal to tangent squared theta plus 1. That's what I want to use. So right here, in parentheses, instead of writing secant squared theta, I'm going to write tangent squared theta plus 1. And then that worked out perfectly, because now the rest of my equation, they all have tangents in them. And that is exactly what we wanted. We wanted to deal with an equation that only has one variable in it. So let me rearrange this just a little bit. Tangent squared theta minus tangent theta. And then I have a positive one and a negative one. That becomes 0. So forget about the constants, and that whole thing is equal to 0. Now, a lot of people kind of got confused at this point. They were like, I don't know how to factor that. I have no clue. But this is the exact same thing as x squared minus x is equal to 0. There are not 3 terms. You don't have a constant. So you can't factor this in the normal way that we think of factoring with 2 sets of parentheses. But what I can do is pull out a common factor. I can pull out an x from both of those, and I'll be left with x minus 1. So if you ever are having a hard time looking at an equation like this and you can't figure it out, try to just think about it in terms of x's for a second. So I'm going to do the same thing up here. I'm going to pull out a tangent theta, and I'm going to be left with tangent theta minus 1. It's nothing new. You already know how to do this. It's just kind of introducing it in a new set of, I don't know, in a new light. Now we have 2 different options. We have tangent theta is equal to 0, and we also have tangent theta is equal to positive 1. Okay, so let's figure out where tangent theta is equal to 0. It's not, when it's equal to 0, 0 is kind of neither positive nor negative. So it's not really like we have answers in different quadrants, but what we can do is, remember back towards the unit circle, when we were thinking about things in terms of tangent, and we viewed tangent by thinking about it like this. Everything that is along this line, that is a vertical line, so it has a slope that's undefined. So that means that the tangent of 90 degrees and the tangent of 270 degrees are both undefined. But if you look at the things that are on this line, which is a horizontal line, which has a slope of 0, everything that's on this line, tangent is equal to 0. So at 0 degrees, at 360 degrees, and at 180 degrees, tangent is equal to 0. So we actually have 3 different answers just from this one little statement. Now, I want to warn you, because these questions were just example questions that we were doing in class, so it wasn't really a long written out thing. So we don't have, the interval written out anywhere. But if this question said, find all values of theta, where theta was less than or equal to 0, or I'm sorry, greater than or equal to 0, less than or equal to 360. Because it has the less than or equal to sign right here, that is what would give us the right to include the 360 degrees in our answer. If there was not a bar under here, and this was solely theta is greater than 0 but less than 360, and you didn't see that bar underneath there, then you would not be able to include the 360 degrees as an answer. But because there's no interval stated on this question, let's just assume that we can include all of our answers, including 0 and including 360 degrees. So from the left-hand side of that equation, I have 2 answers. I have 3. 0, 180, and 360 degrees. But I'm not done because I still have another answer right here. Now, tangent theta is equal to a positive 1. And because it's a positive 1, I'm going to do all students take calculus and figure out where tangent is going to be positive. Tangent is positive in the first quadrant and in the third quadrant. So I'm going to have 2 answers there and there. So positive 1 is actually on the magic table. If you have that out in front of you, you can see that tangent theta is equal to positive 1 when theta is 45 degrees. You could also use your calculator to figure that out. Second tangent, positive 1, hit enter. And then we need to know the answer down here in the third quadrant. So this is 180 plus theta. So that's 180 plus 45, which is 225. So you have 2 more answers. You have 45 and 225. And you have to include every single one of these answers if you want to get full credit for the question. Those are all the values where the statement above is true. Okay? So that is that question. Let's see how many more we have. All right, only one more question and then the homework assignment.